In the last lecture, we looked at thread locals. The thread local variables have a scope within the thread. One good thing about thread locals is that if you create a child thread, the thread locals from the parent are not automatically carried over to the child. The child may never access the parent thread locals, and so there is no point in making that visible to the child by default. This design is on purpose so that we get good performance and also control the memory inside the JVM. But this advantage is also a disadvantage. There are times when we want the child thread to have visibility to the parent's thread local. Let's say you stored the user and its security attributes in a thread local variable, and you spawn a new virtual thread or platform thread. The child thread may like to know the user information and these security attributes. That seems reasonable. So in order to satisfy this requirement, Java provides us with a class called InheritableThreadLocal. This class extends from ThreadLocal class, does everything that the ThreadLocal does, with the added ability that when a child thread gets created, then the inheritable thread local gets copied over to the child. As a programmer, the inheritable thread local class can be used almost exactly like the thread local class. Here you see the declaration of the inheritable thread local variable. This time we are using the class called inheritable thread local instead of thread local. You can use the get and the set methods on these thread local objects almost exactly the same, no change over here. And then use the remove when not needed. These methods work exactly the same. The only difference is that when a child thread gets created, the inheritable thread local values get copied over to the child. But how exactly is this copying done? By default, the child value will be identical to the parent value, meaning that the child and the parent values would be pointing to the exact same object. This may be what you want, or this may not be what you want, because this has synchronization implications. Let's look at a concrete example of how this works. Here's a class called InheritableThreadLocalPlay. Right over here, we declare the InheritableThreadLocal variable. Over here, we set the user, and when we print it, we get the user main. No difference here. This is as expected. The code goes ahead and starts a new virtual thread and passes a lambda as before, and we go ahead and set the thread name within the lambda. Everything within the lambda is being executed in a new thread called Bob thread. So what gets printed out here? Since user is an inheritable thread local, the get method will get user main and not null. Because when Bob thread got created, user variable got copied over to Bob thread from the main thread. The JVM did that for us. Now at this point, I'm going to set the ID of the user to Bobby from main. Note that I'm changing the user object itself and not setting the user thread local variable. So what gets printed in the next line is user Bobby. That's as expected. Now let's switch over to the main thread. Once Bob thread terminates, the main thread, which was waiting on the join, now wakes up, and what do you think it prints in the next line? It's going to print Bobby. The reason it prints Bobby in the main thread is because the Bob thread changed the exact same user object that both main thread and Bob thread were pointing to. So the output of the program will look as follows. You can see the line number 3 where Bob thread prints user main because it got copied over from the main thread. You can also see line 5 where the main thread printed user Bobby. Comparing 4 and 5, you see that the inheritable thread local variable user is pointing to the exact same user object. You can see that by the user reference. The implication of this is that the user class must be written in a thread-safe manner. Its methods need to be appropriately synchronized. Let's get some more insight into inheritable thread locals. Java's thread class keeps a copy of two maps, the regular thread local map, but also an inheritable thread local map. Values of the inheritable thread locals go into the inheritable thread local map, whereas the values of the regular thread locals go into the thread local map. Now here you see three inheritable thread local variables in the thread map. Thread 1 also has a thread local map that is separate, and I'm not showing it. Now you can also think about thread 1 as the main thread from the previous lecture. At some point when a child thread gets created, right here it's spawning a new child thread, what happens? During the creation of the child thread, one of the things that is done is a copy of the inheritable thread map from the parent is used to create the inheritable thread map of the child. Right here, the map gets created. And as you can see, the default implementation of the user, which is an inheritable thread local, is just copying the value to the child, which means both of them are pointing to the same user object. Now you can think about this child thread as Bob thread from the previous lecture. By default, all the values would be copied as it is. So you see the user reference pointing back to the same user object. This is exactly why when Bob thread changed the user object, it got reflected in the main thread as well. But what if you do not want the default implementation of child value? Well, we are in luck. We can change the default implementation by overriding the method called child value. It takes the parent value and then we can return whatever we want to set as child value. What you see on the screen is a creation of the inheritable thread local object, but I am providing an implementation of child value method where a new user object is created from the parent and returned. Also, I overrode the method initial value, which will return anonymous user. Now let's see in the diagram what happens if we create an inheritable thread local in this way. You see thread 1 with inheritable thread local map. When the child thread gets created, what happens? The inheritable thread local map gets created from the parent, but the child value method is called on each inheritable thread local variable to get the child value. So what we see now is that the user variable of child is pointing to a brand new Java object and not the same object of the parent. This is the result of our defining the child value method while creating the inheritable thread local variable. So essentially now user becomes a thread safe class again. But the implication of this is that the child cannot propagate any changes back to the parent via the user object. So choose your design very carefully depending on your requirements. What happens if we run our example with this new way of creating the inheritable thread local object? Now here's the same inheritable thread local play class, but with the new way of constructing the object. It has a default value which returns an anonymous, and it also has a child value which returns a new copy of the user object. The output would be the following. You can go through this output and match with the print statements, but essentially if you look at line 1, it prints anonymous and not null. And also line 4 and line 5 point to different user objects. Whatever we did in the Bob thread did not affect the main. Now this concludes our discussion of inheritable thread local variables. Thread local variables remain a viable way to design your systems and work with both platform as well as virtual threads. In the next lecture, we will talk about some of the downsides of the ThreadLocal variables which you should be aware of. If you like this video, support this channel by giving a thumbs up. And don't forget to subscribe to this channel for more quality content.